Hello everyone. Can someone please confirm if I am audible? Hello everyone. Can someone please confirm if I am audible? Hello everyone. Thank you, Shubham, for confirming. I'll just wait for a few more minutes before we begin. I'll just wait for a few more minutes before we begin. Okay, it's time now. It's already 10:05, so let's quickly begin. Hello everyone, good morning. I am Faisal Khatri, as you all know, and this is a session with regards to API testing with Playwright TypeScript. And let's quickly learn about what we will be discussing in this session today. So we will talk about Playwright, how to install it and set up with TypeScript. We will also learn about how to test get, post, put, patch, and delete APIs, how to perform assertions, how to make use of the global setup in Playwright. We'll also touch some points related to the fixtures in API testing for uh, validating the tokens and all, and using it in the test. And finally, we'll perform some test execution and check a Playwright report. I'll not be going deeper into this tutorial. We'll touch upon some of the points, and later, if you have any questions, we can ask me at the end. So, the first step is to start installation. Let me navigate to a repository. Sorry, let me navigate to a new folder. Let me create a new folder first for creating this repository. To install Playwright, we need to type in the command in npm init playwright@latest and click enter. So as soon as you enter this command, it will ask you a few questions, and in a guided way, we can create a project for Playwright TypeScript. So its first question is, do you want to use JavaScript or TypeScript. So I'll select TypeScript. Where do you want to put your end-to-end test? I'll keep it default test. Add a GitHub workflow. Yes. Install Playwright browsers. Can be done manually via npx playwright install, but I'll do this by default. So let it be true. And it's now creating the project, installing the browsers. It will download all the browsers that are required by Playwright, and then we can begin the testing. So give it a few minutes to get these browsers installed. In the meanwhile, Playwright can be used for web as well as API testing, and it supports multiple languages like Java, TypeScript, JavaScript, Python, and .NET. And you can create projects for performing your web as well as API automation. It provides multiple features like there are semantic locators. You can locate by role, by ARIA role, by text, by placeholder, and all. It also supports API testing, so you can perform all the basic level API testing like getting a post request, uh, hitting a post request, get request, put, patch, delete, and so on. You can also perform different assertions it provides, and it also supports reports out of the box, and it also runs seamlessly in the GitHub Actions as well as the CI/CD pipeline. So we can see the Playwright has been installed. After installation, it has provided us with a list of command to run the end-to-end test. We can run the command npx playwright test. In the interactive mode, if I want to start it, you can run the command npx playwright test UI. Then if I want to run on a specific browser, I can select and run this command. Similarly, it has listed all the different commands that I can use to run the Playwright test. Now the project has been generated. Let me open this project in VS Code and see what all things were generated in this project. So I generated this project in GitHub and Playwright session folder. Let me open it. So you can see generated the package.json folder. This is the package.json file. This is the most important file. Consider it, if you are a Java user, it's like a pom.xml. It contains the details about the dev dependencies and the project details as well. So you can see it has already added the dependencies for Playwright and types node. The version for latest version for Playwright is 1.61.1, and for types node it's 26.1.1. It has also added the Playwright config.ts file. This is also an important file because it contains the default configurations for running Playwright. The test directory path is mentioned here. The fully parallel is set to true. You can set it to false as well. Forbid only, retries. Reporter by default is HTML. There are different projects. Like I said, it supports running test on Chrome, Firefox, and WebKit as well. So those projects are by default listed here. And that is all for the default settings from the playwright config.ts. It has also added a few tests, but it would be more on the UI side. It does not add any tests for the API automation or testing. So this is just one example test to give you an idea how to write the test with Playwright TypeScript. And since I selected that GitHub Actions to true, it has also added a CI workflow for GitHub Actions with regards to the pull, push, and all other details how this action should run. So whenever I push this project on GitHub, it will push on the main or the master branch. If I push this project on the main or master branch, it will start running the project there. Then there are different jobs like test job, and it also generates the Playwright report. It will in this job it will install the dependencies, the Playwright browsers, and then run the test. After that it will generate the report. So that's all about a basic idea about the project. These are the basic things that get generated with the default Playwright installation. Talking about the prerequisites for this, we need to have Node.js 20 or higher installed on your machine. You need to have a IDE. So I'm basically using VS Code for writing the test. You can use your own IDE in which you are comfortable working with. Now, let me tell you about the default. Sorry, let me tell you about the application under test. So the application that we will be using in this demo. So I have created this Restful E-Commerce application. It's a Node.js based free to use e-commerce APIs, and we will be using this project for testing the different for writing the different API tests. You can check out the installation steps. It's given in the README. You need to clone the repository, navigate to the root folder, and create a .env file. Copy paste these values in your .env file, and then run npm install and npm start. So if you are having Node.js, this is the installation steps for it. If you want to start it using Docker, you need to do the same steps like clone the repository, navigate to the folder and .env file. After that, you need to copy this .env file and then run this Docker command. It will start the application on the localhost colon 3004 port. The Swagger is exposed on localhost 3004 slash API docs. If you start the application on using Node.js, the same URLs can be visited to check out the application. If you are running it with Docker, you can stop the application by running the command docker compose down. -f refers to the file name. So if you have just single docker compose file in your project, then you can directly run the command docker compose up and docker compose down to start and close the application. But if you have multiple files, it's better to give this -f and then the file name. I have already cloned and this repository. So I'll quickly run this using npm start. And for one more detail, like if you want to check out the documentation, what all API it has, so here is the API documentation on the wiki page in the project itself. So you can check out the different APIs that I have created here. So there is a health check API, there is a post order API, there is a get, put, patch, delete, and every API is there for performing the hands-on API testing at your local machine. There is an post image upload API for and create token API as well. We will use this create token for generating the token. So let me quickly start this RESTful e-commerce before we begin with the testing part. And we need to visit localhost 3004 API docs. So once this is started, you will see this kind of a Swagger coming up on your browser. So this is the post add order API. Then this get all order API actually fetches all of the order in the system. Like I said, this is an e-commerce demo application which contains different APIs for creating an order in the system, getting all the orders, getting specific order with regards to the ID, user ID, and product ID. And you can update the order using put request, and there is a patch request as well for updating the partial order, and finally the delete order as well. One thing more to note here is there is an authorization button here. For the post and the get APIs, it's not behind the authorization, but for put, patch, and delete, you will require authorization token. That authorization token can be generated by using this post auth API. So let me try it. The username and the password for this is already given in the wiki page. So whenever you are using this create auth API, it's a post API request. To create the token, you need to use these credentials. admin and then secret pass 123. So let me quickly add this admin execute. So you'll see the response code is 201 and there is a body coming in with the token as well. So we need to copy this token and paste it in this authorization window with the value. Click on authorize. So now the token has been accepted successfully, and now we can go ahead and add the different orders in it. So let me quickly add a single order here. User ID 1, product name iPhone. Let's give it as 300. 1, text amount 12. So the total comes to 312, and then click on execute. So this is how the response is returned. It returns a message with orders added successfully and then an array of orders. One thing more to note here, if you just check out the request body, it accepts array of orders. So there is an array which contains multiple order objects. That is, you can add multiple orders at the same time. And once the order is added successfully, it returns that list of orders in the array. And with the message orders added successfully, the status code is 201. Similarly, there are multiple scenarios that can be used here. You can see the documentation. 400 response code is returned if you do not supply an array of orders, and if you miss adding any order fields in the object while creating the order, sending the request body. Similarly, get all orders will fetch all of the orders available in the system. If you just try it out, we have just created one order and it fetches the orders that we just created. Similarly, there is a get order API. It will fetch the order with user ID, product ID. So you can just filter and play around with these different APIs that we have. For the put order API, you need to add the order ID first. So while we generated this order, the ID was created here, and we can see it in the response in the post add order API. So we can use this ID, and we will also need this object of the order for updating the order. So we need to add the ID of the order and the object. One thing to note is between patch and put request is for updating a order using put request or any put request that you take, it will requires the full request body. You need to send all of the fields in the response body even if you want to update a single field in the request. But in case of patch, you do not need to send full body. You can send the required field that you need to update. So for example, I need to update it from iPhone to iPad, and I need to update the amount to 500. Then also I'll have to send all of the fields with the required value. All the fields that do not want to be changed needs to be kept the same. The field that you need to update needs to be updated accordingly, and then 512, and then click on execute. So here you can note in the curl request, you can see it is sending the put request on this URL. The URL is update order. It accepts application.json format and the authorization token. The token that we added in the authorize window previously from by creating it from the post auth API that has been supplied here as an header, and the content type is application/json, and this is the body that has been sent. So you can see the response says 200. That means it was successfully updated and the order was generated successfully. This was just to give you an overview about the application under test. So while we use this application, there are no doubts like what exactly are we updating and what fields are we using to update. Now let me quickly move to the Playwright. We already installed Playwright by writing npm init playwright at the rate latest, but I have created this project at my local which contains all the tests that I'm going to demonstrate today. So let's start one by one. So first we will learn about uh, adding a post request. How do you create a post request with this Playwright TypeScript? So there are four different ways to send the request body in the post request. The first one is you can directly send a raw JSON object or array. So let's quickly check how we can do that. So this is the structure of the test that we can write. You need to write test, and inside that the name of the test, post order details API with static JSON array, async, and request. So before we move to the request, let me quickly tell you about what this request actually means. The request is an instance of API request context which is provided by Playwright. And you can think it of a HTTP client, like how a browser knows to visit web pages and Postman knows how to execute or send the API request. It's the same thing. It exposes methods such as post, put, patch, delete, and so on. And this request is actually responsible for sending HTTP request, managing the cookies, and receiving responses. So this particular thing which you see here is called as a fixture. So Playwright provides the built-in request fixture, so we can use it directly in the test. So you can see we have not created any import statement here for importing the request. This is a built-in Playwright fixture which gets imported as soon as we type it here in the async. And then we can write this statement const response. So we are storing this, whatever values we are sending, we are storing it in a variable called response. So here, how if we want to send a post request, we'll write await request dot post. Like I said, this request is a API context, is an instance of this API request context, and it exposes this post method. So inside this post method, we need to write the URL which we want to send. So in our case, the API post API has a uh, post slash add order. This is the endpoint of the post API request. So we will be using this slash add order. The base URL is localhost colon 3004. This is the URL where our API server is running. So we will use this HTTP colon double slash localhost colon 3004 slash add order and slash. Now to send the data, like I said, the post add order accepts the data in a array format and which contains multiple arrays. So let's create two order objects. The first order object is this one. This is the second order object. So the first order contains details about Cadbury bar. The second order contains the details about Milky bar. After we send this request, we can run a expect statement. This variable stores the response details, so we can check response.status and then to be 201. So this particular test will verify after sending this post request with this request body, the status code should be 201. The next thing that Playwright allows is to use json.stringify. We can use json.stringify as well to send the request body. And json.stringify can be used for sending raw payloads, testing malformed JSON, or sending custom formatted JSON. The content type header is most important here because we need to let Playwright know that we are sending the request in a JSON format. And this particular header interprets to the request body as a JSON data to Playwright. So the thing remains the same, like you create an order object. We already know that the order request body needs to be in the array format, so we have added these fields here, and request dot post. And then I think I forgot to mention here, like request dot post, we need to have the data property. This data property attaches the request body to the post request. If you do not give this data, then the request will not be sent correctly. We need to make sure that we add this data property. Same here, request.post the data, and here we are supplying json.stringify order data. After that, the headers can be supplied here with the header property. The value is, it takes the value in a key value format, content type application slash json. This particular statement sends the post request with json stringify. The request payload is taken from this variable order data, and then we perform a kind of a verification, response.status to be 201. It just verifies that the response status code is 201, which means the request was successful. Another approach that we can use for sending the request body is using the JSON file. So it makes the test more clear and like concise in format. So we can use the JSON file directly for sending the post request. You need to call this data property and then the variable. This order is particularly coming from this orders.json file, and in this test I have already imported this. Import orders from the path of the file, and then type should be json. Now when this comes into the effect, let me tell you about this tsconfig.json. We need to have this compiler options in place. I have set the module as node next, module resolution node next, resolve JSON module true. This is important. Since I have resolved this JSON module to true, that is the reason why I can import that particular JSON file easily with the type :json in the test, like you see here. Import orders from this path file, this file path, and then with type JSON. So this will import this particular order, this file, and store it in this object, and this object is directly supplied to this data property, and Playwright will take this request, send hit this post API request to this add order endpoint with this request payload, and then an expect statement will run that will verify that the status code 201 is written in the response. Another approach that we can use is we can generate the data on runtime using the faker library. Like for status data, it's very difficult sometimes while you are working on real-time systems. You face difficulty like there is a duplicate order generated, you cannot send the fields duplicate value. So this faker library helps a lot in that case. So how we can use that? For using faker library, you need to install you need to run npm install @faker slash @faker -js slash faker, and this will install the faker library. Once this faker library is installed, you can go to package.json and verify if it is correctly installed. So in the dev dependencies, you will find this faker.js installed. After that, you can use faker.js. I have created another test here, and since you know the different fields that we have in our test, we can use those faker values on those fields. Like for example, to generate a product amount, since we are using TypeScript, you need to provide the type as well. Product amount is a number, and that number should have a random value between 1 and 100. Faker.number integer minimum 1 and max 100. This particular line adds a fake number, a random number between 1 and 100 for product amount. Similarly, for the quantity, it should be a number and should be having a value between 1 and 5. Text amount, similarly 2 and 10. Total amount is also a number, but I have used a formula here to generate the total amount. Product amount multiplied by quantity plus text amount. So this will generate the total amount. Then finally, once these values are generated using faker, I return the object that is required for the request payload. So here in the user ID, I have again generated a fake value for the user ID, product ID. For product amount, again, I'm using faker libraries, commerce function, and then using the product name function to generate a random product name for the product name, and then product amount comes from the value that is generated here. Similarly for quantity, text amount, and total amount. Once this create order details is generated, you can use this helper function to create random orders. Like if you want to generate multiple orders, we can use faker.helpers.multiple. So it takes two parameters, the create order details and the count. So it will, this multiple takes this first parameter, what do you want to run multiple times. I don't want to run this create order details, and how many times do you want to run it, that particular count here. So we'll use it in the test. Here you can see I have generated uh, a test here, that post order details API using Faker library. So it will generate random orders, 5 random orders, and then it will send it to the data property, and accordingly Playwright will send the request. One thing more to note here is it particularly returns this create and random orders, returns the values in the array format. So you don't have to worry about the adding the particular randomly generated order object to an array. So this create random order automatically generates into the array format, which is required by our post add order API, and we can use it by calling the same values, like await request.post, the link to the post API, and then data order data, and then content type with the header content type application slash JSON, and then finally we can run expect statement to check that it is returning 201 status code. We completed this post API. I will not be running it now. I'll run all the tests at the end, and we'll check out the report together. The another aspect is to check the get orders. We have already created some orders into the system. Let me check this get order details. So the get order, the get API ideally is used to fetch the records from the system. So whatever you have generated or whatever data that is available in the system's database, that can be fetched and retrieved and verified using this get API. So there are multiple things that to note for using a get API. So we can verify the status code first. Let's check how we can verify the status code. To send a get request, we need to change the method. So for for post we were using request.post. For get we will use request.get. This get method along with the URL. So the URL is slash get order. You can check out the Swagger for these details, and you'll see here there is a slash get order. This is the endpoint name. It has 3 different parameters that are optional. You can see there is no mandatory mark here: ID, user ID, and product ID. And whenever an order is returned, it returns the status code 200 with message order found and the array of orders. So this makes things easier for us to verify, like what all things we need to verify and how the data is returned in the response, so we can write the automation test accordingly for it. So here request await request.get localhost slash get order and parameters. So this particular thing will add the parameter user ID 1. It will, so we are asking Playwright to get the order which has the user ID 1 with the content type application slash JSON, and verify that the status code 200 is returned in the response. Note here that we are just verifying the status code. I'll talk about verifying the different fields and the different ways that we can use to verify the data in the assert the data in the response. So this is the simplest way to send a get request. Request.get the base URL. If you want to send the params, this is optional. You can send it, otherwise you can remove it. So it will fetch the order accordingly. And then the headers also, this is optional. You need to check your API documentation if there is a mandatory to send a param or a header. But if it is not mandatory, you can ignore these things and directly send this get. So it will say get the hit the API and get the details, and then you can verify response.status to be 200. Again, if you want to check a negative scenario, like I just want to verify that there is no data available, so I'll send a invalid ID 222. This particular order is not available in the system, and then it should return 404. So this is how you can perform negative testing as well. Another scenario is to send test get API request with multiple parameters. So many a times, if you just talk about, if I talk about the real time API automation projects, we can check out that it supports multiple parameters to filter the records. I will be answering the questions in the end. So just I know there are few questions there, but I'll answer about that in a towards the end. Let's just focus on the Playwright TypeScript project now and understand the explanation that I provide for writing the APIs. I'll come back to your questions. So get order details with multiple parameters. I was talking about like in corporate projects or real-time projects, you might have get APIs with multiple parameters. If I talk about the e-commerce application, there are multiple filters that we see on the web page. We can filter data according to the price, the product name, the availability, the ratings, reviews, and so on. So accordingly, all these values are filtered using the parameters that are added by the get API, which fetches the data. So the same way, if you want to add multiple parameters for verification, then you can use ideally define a parameter object and then supply it to the parameters, or else you can supply it using the params and then add an object to it. This both of these things remains the same, like params colon and then the value for the parameter, or either you can define a param object and then send it to the get request. Both of these things works, but I prefer this way because it makes things clear for me. I don't have to update the code again and again. If I want, I can again take it to outside the code, add it to some JSON file and then send that particular thing. So if I want to update it in future, I can just update this object. I need not change the code. So the in this multiple param test case, it will set the ID to 1, user ID to 1, and product ID to 79. So accordingly, it will filter the record which has ID 1, user ID 1, and product ID 79, and respective record will only be returned in the response. If there is no record available for this particular filter, then it will throw another status code and where the test will fail. So we can understand that this particular thing is not working. Or if you want to verify negative scenario, then you can update the status code as 404. Like I said, there are multiple things that we need to take care of while working with API. Parameter is one such thing, and then we have the headers as well. So you can add the headers also in the request test, and that can be added after this headers, these parameters. Or ideally, you can also change the position. It doesn't make any problem out there. It doesn't so these headers can also be moved to the top, parameters can be shifted down. Either way you can do it. If you want to send headers, you need to have this header property, and then whatever header content type or if there is any other header property that you want to send, you can send it. Ideally, I am sending a content type application/json. In case of post request, while sending XML request or form data, you need to accordingly send that www URL encoded format or form data format and so on. That can be also used using this header property. And then the expectation is run. You can note here, like for every test I have added an expectation, so that I'm sure like whatever thing I'm sending, it runs fine. and accordingly it will help me a lot while reviewing the report, as well as if my test runs in the GitHub Actions pipeline, then also it helps me a lot to check which test passed and which test failed. There is another option with timeout. There is another option with timeout. Give me a minute. Okay, so this timeout method you can send, and this is actually a setting for timeout to limit how long to wait for the response. So if you want to check the performance of the API, like if you are having a get API and you want to check the performance, how fast the response is coming in that particular API, you can verify that by adding this timeout value. The timeout value can be changed. This is in milliseconds, so I have set it to 300 milliseconds. You can increase it according to your according to the value that you want to set and verify the performance. The timeout is set to 300 here. Ideally 300 milliseconds is more than enough. You can make it lower also, but you can increase as well, but ideally 300. You can check it with your developer as well. If there is a performance related issue, then you can just verify it, like it should come under 100 milliseconds, 50 milliseconds, and so on. But ideally 150 milliseconds is too low. You can increase it to 200 or 300 milliseconds. Ideally for us API to respond, it should be within a second, 1 second, and 500 milliseconds is good. But for in case of e-commerce or complex applications, it makes difficult for the end users. This timeout refers to the amount of time the get request will take to fetch the data and show it on the front end. So ideally it should be lesser time, and the API should respond in a quick manner. Similarly, you can also add this fail on status code parameter. This is to verify if you don't want to check the status code again and again in your API test. You can just use this fail on status code option that tells Playwright to automatically fail the request if the API responds with the status code non-state which is not between 200 and 299. Ideally for 500, 404, 404, 400, 500, etc. If the API responds with a status code which is not between 200 and 299, then this fail on status code will fail the test. So I have set it to true. You can set it to false as well. That means do not use this. If you set it to true, it will use this. And you can note here I have stopped using this I'm sorry, I lost in between. There was some internet glitch. Are you able to see my screen now? Are you able to see my screen now? Please do respond. Okay, I'm extremely sorry. I lost the internet connection in between, but it's working fine now. So I was talking about the assertions and the response verification. So ideally, we can verify different things in the response. We can verify the uh, field values. We can verify if the property or the structure is fine or not. We can also verify if the response body is an array, and we can verify the values if they are greater than, less than. We can perform string verifications and object and the order array and so on. I'll explain one by one. So the response structure checks to ensure that the API consistently returns. Let's start with the response structure first. How do you verify the structure? So the response structure ensures that the API consistently returns the response in a expected format. Like for example, I said for this request, I'm expecting the get order API to return the response in a respective format. That is, it should return an object which should have a field, message, and then an order which has an array of orders, right? So we can verify this structure if it is coming correct or not. First we need to send the request.get the URL, and then the parameters, and failed on status code should be set to true. Ideally you can ignore this fail on status code as well, and if you want you can add the expect statements as well, but I'll keep this fail on status to true. And then this response is object, whatever response object we get from the get API, it's stored in this response variable, and after that we will generate this response into a JSON format and store it in a response body variable. So whatever response we get after hitting this get request is now stored in this response body variable, and then we run this structure check by expecting the response body to have a property of message. So here we see that it should have a property message. It will just check that this message property is displayed, correct? After that we'll run another check to verify that the response body has a property orders. Similarly, we will run a property check again to check that the response dot orders of 0. We know that the orders is an array, so we can verify that the first object in the array has a property ID. So ideally, if the orders is an array and it is returning an object, then that objects will be of the same kind throughout the array. So we can verify the first order object when check that it has a property ID in it. We can also verify the other property, like it should have a product name, right? Similarly, you can add more assertions if you want. The response body dot orders has user ID, product name, product amount, total amount, tax amount, and so on, like you want. After this, let's do some basic level verification. So ideally you will see that we are sending the request in the same format. We are just retrieving the order with the user ID 1 and then checking the fail on status code is set to true, and extracted the response.json to the response body variable. And then to perform an assertion on the value, we will write this expect response body dot message. So this response body is the JSON that we get in the response, and dot message, like response body, the field name message should be to be order found, right? So you can see this message should be order found. So we are performing this assertion to check that the message should have order found. The next assertion is array.isArray response body dot adders to be truthy. This particular line verifies that the orders should, in the response body, orders should be an array. That is what the verification means. Similarly, we can also check that the order array that we get in the response should be greater than 0. So in this order, for the user ID 1, I am expecting that the order should return at least one object in the response. And that is how we can perform to be greater than. Similarly, you can perform other assertions like to be less than, to be equal, and so on. Now let's do some verification for the order values or the response values. We can use the same thing, like we can hit this API. We'll fetch the user ID with the value 1, user ID 1, and store that response in the response body variable. And then we'll also fetch from this response body, I want to fetch the order, first order that I get in the response. So this order object contains the first order object. So ideally, if it returns this, so this response body is this full object, then we extracted this order's first object. So this is what we are extracting now, and we are running the assertions against. So this order.order ID should not be null and should be defined. So this makes sure that whatever order we get, it should have an order ID, and that ID should not be null, and user ID should be equal to 1. Product ID should be equal to 79, and product name should be 5-star 10-gram chocobar. So this is how we can perform different assertions. This order object, this is the order object, and these are the fields that I'm expecting to be there in the order object. And this is how I perform the different assertions. I can perform another check by matching the object and array as well. So Playwright provides another leverage to perform assertions by matching object and array. The style for writing that test is similar to this part. Like we hit the get request with the user ID 1, fill on status code true, and then store the response body in this response body variable. And then we expect response body to match object. Why I'm using match object here? Because this response body contains an object, JSON object. Like I showed you here, this is a JSON object. So this JSON object, we are performing assertion to check this response body should have this object, which should have a message order found, and then orders should be an array containing an object. I hope you are getting these things here, because it's simple to understand. If you just know the structure of the response body, then it's very simple to understand. The orders should have an array which should have an object, and that object should contain these values. So this is how we can, in a very easier manner, we can verify the structure, the style of the response body, as well as the values as well. So we are verifying two things here. We are verifying that the response body should be an object, and then it should have the field message with the order found. Order should be an array, and it should have an object with these values. This makes things pretty clear. I would support and use this kind of a expectation as a best practice in my test, because it performs multiple assertions at the same time and provides me with the compact result as well. So if anything goes wrong here, so for example, if this comes as an array, or if this is not an object properly created, then I'll get a failure here. Similarly, if orders is not an array, then I'll get an array here, like an message here or an error here stating that this is not an array. And if this object is not properly built, then also I'll get an error. And if any of these fields are missing, then also I'll get an error. So it's a kind of a win-win situation for us for performing the assertions. We can also hit the get API. These assertions, one thing to note is, can be used with all other APIs as well, like post, put, patch, delete, and everything. Delete does not return any response body, so forget about delete. We cannot perform any assertions in the delete request. But ideally for put, patch, delete, put, patch, get, and post, we can perform the same assertions in every API. It's not necessary that we perform these assertions on the get API only. And then request.get, the things remains the same. We store that response body in the variable. We store the response body in a response body variable, and then we verify that the order object, first order object, should match this particular thing. So ideally this was the full verification that we did. This particular part, expect object containing, we can write it in this fashion as well. Expect order to match object, these all things. And it's not necessary you provide all of the objects here. You can provide the respective verification that you want to do. So it shows like to match object, and here you see object containing, so it will perform assertion to check if it contains all of these values. It's not necessarily a strict check to check that object contains all of these fields, like object matches all of the fields. If there are more fields also, it will pass just checking these fields. But in case of this verification, it will particularly match the object and then check these fields are there in it or not. If there are multiple fields, then also it will pass, but it will particularly check these fields. Now if I want to write the test with the best practice, I can write it in this fashion. Request.get params user id 1 fail status code true, and then I'll store this response into a response body, another variable, and then verify that the message contains order found. The order's length should be greater than 0. That is what I'm expecting, because I want this to return some value from the get request. And then I will check that the response body dot orders, that is the main thing that I want to verify, because I've already verified the message in the first line. I will check that it should have an array and an object containing these values. So if it contains these two things properly, I can assume that the API is returning things correctly. But if you want to do a more stricter check, you can verify one by one the properties, and you can directly match to equal all of the values that are written in the response. It all depends how you want to perform the assertions. But ideally, if these things are working fine, then I should expect that the API is actually working as expected. And all of these things remains the same, like checking the things here. The assertions remains the same here. Let's check about how we can extract some value. So for example, if I want to extract this if I want to extract this ID and use it in some other test, how we can do that? Let me explain that now. So first we will extract the store this response body first object that is provided in the orders array. The zero array starts with 0, so this is the first object in the order array. And then I'll verify that the ID is not null, and then I'll store this order.id to the order ID variable. And this is just to check that the order ID contains the value for the order ID. Similarly, I can also extract the product name, user ID, product amount, total amount, tax amount, and so on. This is how we can extract the values from the API. The same approach can be used across multiple APIs like post, patch, put, and so on. There's one more important thing to note here. If I want to extract some like attach some values in the response, how I can do that? So ideally in the Playwright report, by default you do not have the data for the response body attached to it. We can attach that data also by using this testinfo.attach method. And for attaching the values, we need to construct some of the values and store it in some variables, and then pass on these variables to the attach method. Here I'm hitting the get request with the user ID 1 and then verifying that it returns 200 status code. This is just to check that the API returns things successfully. And then I am storing this status code, the status text, headers, and then the body. Correct. And then I'm generating a full response by adding this order, this particular object, which contains status text, headers, and body. These values comes from these variables here. And then I'm attaching it to the testinfo.attach, and I'm giving it a title, full API response. The body is stringified JSON with a full response, and content type should be application/JSON. Once you attach this, you will find it the particular values attached to the Playwright report once you run the report. That was all about the get API and the response data verification. Let me quickly jump to the put API now. Like I said, put API, if you just check the put API, you require a authentication token as well to make this API work. And that authentication token needs to be supplied as a authorization header. And then we need to supply this bearer token. So to generate this particular token, we need to hit this put API, the post API with the auth endpoint, and then use these credentials. Then it will generate this response message with authentication successful, and the token will be generated here with a 201 status code. Now, if you check, this post auth API needs to be used for updating as well as deleting the record. So for put, patch, delete, everything you need to hit this auth API. So hitting this auth API again and again will create duplicate test or duplicate lines of code in the project. So we can particularly avoid writing multiple lines of code in the project by creating a fixture for that. And how do you create that fixture? I'll just show you next. So we'll create a auth.fixture, and this is how we write it. We need to import test as base and expect from this Playwright. So it's just like creating a base fixture for us. And I'm using this .env module from Node to load the environment variables, since it is a best practice to have the credentials loaded from the environment variables rather than directly hard coding it in the text. So I have created this .env file, and I have updated the username and password here. This .env file will not be pushed to my repository on GitHub, or if you have a real-time project, you need not push it to the remote repository. And using the .gitignore, you can ideally write it here, like it should ignore .env file before sending it. So we have created this username and set the value for it, and password also set the value for it. Now in the auth.fixture, I have created the type for this fixture, like it should return a token in the string format. And base.extend my fixtures, this is what the fixture that needs, and it will return a token with by using this async request fixture. The things in this particular function remains the same, like you are hitting the post request for the auth API endpoint, supplying the stringified JSON. One thing to note here, I'm not supplying the username and the password value hard coded, but I'm taking it from the environment variable process.env.username and process.env.password. To access this username and password from the environment variable, I have used this import.env and loaded this .env .config. .env.config. After that, I'm verifying that the status code should be 201, and I'm storing the response body that is returned. So ideally, it should return this response body, message and token. This is stored in this response body, and I'll use this token here, and it will be returned in the fixture. And this is the last export statement, exporting this expect to be used further wherever this a fixture is used. So let now move on to the put request. Update order using put API request. Now note here, I'm importing the test and expect from the fixtures. I'm not like importing it from the Playwright test. If you check out my previous test, like the get API test, I'm importing this test and expect from Playwright test. In the post also, I'm expecting like importing the test and expect from the Playwright test. But in case of put, I'm using import expect and test from fixtures that I have generated. That is the reason why I have extended this base and imported the Playwright test into this. And this particular fixture extends the gets all the data for the required fields for the base and the expect from the fixtures from the Playwright test itself. So in this test put test, I need to import the test and expect from the fixtures. And then the approach remains the same. Get like create an object for the updated order. Now you'll say like this is an object, why I'm not supplying it as an array, because in post order I used to supply an order array. So if you check out the put API, it expects the response it expects the request body in an object format. So we need not supply the array here, but instead we need to supply it in the object. And this id is a path parameter. You can check it out here. It's an integer, it's a path parameter, and it's a mandatory value. So if you do not supply this id, then the API will not work and it will return some error. So we have generated this updated order object. We have set the order id to 1, which will be supplied in the URL. And request.put, this put method will be used to pass on the put method, the update order request. And then dollar and then colon id, this refers to the path parameter. This parameter will be taken from this variable id, and then the data is supplied in a stringified format with the variable updated order. The headers are content type, and here is the authorization token. This is how we supply it. You can note here in the test I've used this token fixture and request fixture. So this request fixture is used here to send the put request. This token is used in the authorization token header, where the token value will be supplied after this particular part has been executed. So it will extract this token and store in the token variable, and that particular value will be used here. Once this is done, we can check the response, like store it in the response body, verify that the status. This is another method through which we can supply verify the status code, response.status to be 200. And then I'm verifying the response body to equal an object containing order updated successfully, and I'll just verify the two fields that I've just updated. This is 124 product ID and the product name is Lindt chocolate. So this is how the put API works. Then comes the patch API. Is the same thing. We will be using the same fixture. Now you see how easy it becomes for us to reuse the same code. So this is also a kind of a best practice to use fixtures in your test, where you don't have to rewrite the same code again and again, write duplicate lines of code. Also it increases maintainability as well. So in case in future if there is a change in the token generation part API, then you need to make change in the fixture itself. You need not change the code in each and every API where you are calling that particular auth API. And in the patch, like I said, it just requires the fields that we need to update. So you need not send the whole request body. It also accepts the request body in a uh, object format. So that is what I have given here. And it also takes in the path parameter ID. So the approach remains the same. The style of writing the test remains the same. The only change here is request.patch. And after that, you need to put the URL with the parameter. I'm updating the order ID 1 again. And the updated order request body is sent with json.stringify, and then content type and the authorization token is sent. After that, I perform the assertions to verify the status code to be 200, and then verify the response body by checking the it contains the message order updated successfully, and then the values for the updated fields. So I have updated this user ID and product ID, the same expectation I'm running here. The last part comes the delete. It's a pretty simple kind of a API request that we need to send. It just deletes an order from the system. So again, to note here, I'm using importing the test expect from the authorization fixture, and in the importing this fixture using this request, async request and token, supplying the order ID as 6. The same order ID is supplied as a path parameter. Headers are supplied, because this is important. Without authorization token, the API will not work. And then I'm verifying that the response returns status code 204. All of the details for the verification and everything you can find on the Swagger. You can find that the delete order has a path parameter, which is an important part and mandatory, and it returns 204. So we can verify that as well. In the patch API also, you can just check. It will partially update the order, and you need to send the respected fields only. That is the reason I have not updated the order object here. You just need to send the respected values, and then it will return this particular thing in the response. You can verify 200 status code as well. There are other tests that you can write by checking the status code 400, 403, and 404. One thing important here, for in case of post put in case of put, patch, and delete APIs, if you do not supply this authorization token, then it will return 403, like token is missing. But if you supply an invalid token, it will return 401, that is unauthorized. So there is a difference between authentication and authorization. You are not authorized means you do not have the correct access for it, but you are available to log in into the system. But 401, that means it will stop you logging into the system. This is not the case here. You are able to use this system, but in case of put, patch, and delete, you would require an authorization token to update or delete that particular request. So that is the reason why we are supplying the authorization token here. Now let me explain you about the global setup as well. For setting the global setup, the first let me make you understand what global setup actually is. So the global setup actually allows you to set the data in your project. So in case sometimes there is a get request that you need to test, but you need to seed in some data into the system previously before you run those tests. So global setup helps in that particular scenario. So it runs in Playwright once before the entire test suite begins, and it is used for activities that are used for creating the test data, seeding the database, and generating the authentication tokens, and so on. And as it gets executed only once, so it is helpful in ensuring that it is efficient and consistent test initialization across the test suite. So to create the global setup, I have already created one global setup file here. I'm importing the request from see, this is not a test. That is the reason why I cannot use a fixture like I was using previously for get, post, put, patch, delete. You would have noticed I was using this async request here. Now in the global setup, since it is a function, I'm importing the request object and the orders also that I want to import and use as a for the global setup. I have used this console.log statement just to check if it is running fine or not. And then I'm using this API context, creating a new context, request.new context, and that will be stored in this API context. After that, API context.post. So this API, post API will be called here with then data property of orders. These orders are set using this orders file that I have here in the test data. Right, these orders will be set by default using global setup. And I will be checking if the response status is not equal to 201, fail to create setup test data. If everything is successful, no error message will be displayed, but I'll see this message, test data created successfully. Once you write this global setup file, you need to go to Playwright config and then add it to the configuration global setup property and then path to the global setup ts file. This will set up your global setup file. So in my project it was required because you see I have given a number for the test here 1 2 3 4 5 6 7 8 9. I am running the test using npx playwright test. So it will run the test in this specific order. So if I have not given this particular number, whatever alphabetically the file name comes up, that playwright will start executing that file. And since my data as well as the test that I have written are in a specific order, I wanted them to get executed in that specific order only. Like the first get order should get executed, then post, and then this post API builder, then put, patch, delete, and then the data driven one. So all of these tests should run one by one. That is the reason why I have numbered this test here. And this get was running first, and as soon as you start the restful e-commerce application, it does not contain any data seeded in it. That is the reason why I was required to create a global setup file and feed it into the system. So at least I have one order available in the system for which the user id 1 will be there. So this user id 1, you can see in the orders.json, I have this user id 1, and it is just validating all of this data only in the get API. So now let me quickly run all of the test. But before that, let me ensure if I have covered everything. Okay. So to run the test, you need to first make sure that your RESTful e-commerce is working. So it's already working. I'll just stop this and start again. So it does not contain any other values there. To run the test, in the package.json, I've already given a script here. So if I run this test, then it will execute this command npx playwright test. So let me run npm run test. And you can see it executed everything. 30 tests passed. That was just in 743 milliseconds. There are some things coming up here. These are the console.log that I had printed in some of the tests, post API faker, in post API builder, and so on. Can you hear me? Okay. Uh, just a minute. Okay. So I'm sorry, there was a power cut here and I had lost everything. So I was just reconnecting. Okay. So the test ran successfully. Let me quickly run the report. Playwright. You can see the command has been provided by Playwright directly after the test have been completed. So you can run this npx playwright show report, and it will by default run the test on your local browser. And you can see the get order test, the details here, get order details, all of the tests that we ran has the details. And we added one response to the report. We attached one response detail, that is what we can see it here. The full response comes here: status text, headers, the body, and so on. This is how the headers the this is how the response looks like once you attach it to the repos. This is very much handy while you work with the CI/CD pipelines. So once you run the test, if you have these things attached, then you can verify what all things appeared in the test. In case of failures, it's easier to debug the things. So it's better if you can attach some of the values, but it all depends upon your requirement. The post order using JSON, then the update order request. You can find out the details here: what it ran, how it executed, what it verified. Everything can be found here. The delete order as well. And there are some other orders that I ran. So that is all about Playwright. Like everyone was telling me to share their GitHub repository. So there are two repositories here. One, this is the Restful E-Commerce, where the API that I was using for demonstration purpose, it is stored here. So you can check this out. I'll just comment it here. The another one, the Playwright TypeScript. This is the second API. Sorry, the second project. So this Playwright TS API testing is the project that I was using to demonstrate and write the test here, and it contains all of the details. I have already written multiple blogs for this. You can check out my Medium blogs. There's already I have created a library for a Playwright TypeScript API testing. It has the global setup, the post API request tutorials, as well as the builder pattern, data driven, push port put, patch, and delete API requests. I'll be adding the get and the response data as well. I have already written that, but that this particular list does not contains the get and the response data verification things. But the blog is already available on my Medium. You can check them out. Similarly, you can also check out my YouTube video where I have supplied different. So you can check out my Playwright with TypeScript, how to test post API request and how to test this get API request. I have these two videos available. I'll be adding more videos for put, patch, and delete, global data setup, and also data driven testing using JSON file, static data, and also using CSV file. I'm in the process of writing a new uh, blog to verify the data using data driven testing on Playwright TypeScript with CSV and Excel files as well. So yesterday I also released one video. You can check this out whenever you have time to create your own local AI QA engineer using Docker, Olama, QNweb 3, LibreChat, and Playwright MCP. You can check out this video as well. It will give you an upper hands on how you can use local AI for performing the testing. So let's now come back to the question part. If you have any questions, please do let me know. I'll be there to answer it. Let's take more 5 minutes and then answer the queries that you have. I see one question that someone posted was why did we use RESTful? So it's a Restful E-Commerce is the API that I have created and used for testing purposes. You can use it for your own machine. You can install it on your local and use it for testing purpose. This is a demo API and it does not contain any like hard coded or new data that could be like uh, problematic for you. It contains all the dummy data inside it. And if you want, you can create your own data using post, add, order API. The API is not real, it is a demo API. You can install it using RESTful e-commerce. Global file requirement. Can you just elaborate what exactly do you mean by this question? Because I'm not getting that. Is it something related to the requirement, or do you want to understand why do we need this global set of file? Okay, so for the global setup file, it runs before any of the tests runs, and it sets up the entire test suite. Like if you want anything to be set up prior to running the test, it is kind of like a basic requirement that you want to have in your project. If you want to have some data already pre-filled data seed in before you run any of the test, a kind of a test setup, you can say, like we have in Java based test, where we set up the Chrome and any other instances before we start running the test. In the same way, you can use the global setup file to feed in some of the data into the database, into your system, prior to running the test, so your test comes up like cleanly, and you can execute all of the tests at the same. It is not a hard coded requirement to have the global setup file in your project, but if your project demands some of the data that you need prior to running any of the tests, then you can use this particular file. And this file executes only one at the time of starting the test. And After that it does not run. So you can just use it for setting up the baseline for your test if you want any. And there are particular, I think I should discuss some best practices as well. So while writing some of the test in API testing, make sure you have proper data setup. Supply the data from JSON files. External resource is always recommended. Instead of using static data in the test, use it from the JSON file. Use proper assertions to verify that field value, the property, the JSON structure. It's better to perform a kind of schema verification as well for the response data. And also you can perform different status code. You can write negative as well as the positive test. It's better to have a word with the developer. If they are already covering the negative scenarios, then you need not cover that in your test. Unit test makes the things easier. If they are already covering certain things in the API testing while performing the unit test, then you need not cover the same test in your test. But it is necessary that you talk about the end-to-end test, the user journeys. For API testing, ideally I would prefer covering the end-to-end test scenarios. Like for example, in this RESTful API, we have get, post, put, patch, and delete. So how you can uh, write the end-to-end test is, since we create the data using post API, so you can use this post API to create the data. Then you can fetch the data using get API. So you can extract the data that you generated using post API. You can extract the order ID from the post API and then pass on that particular order ID to the get API. Similarly, you can filter the data using the get API with the respective order ID, and you can test if the order is coming correctly or not. Then you can use the put API to update the order that you have already created in the system, and then verify if the update order works fine. With the same order ID gets updated, gets reused in multiple tests for the get, post, put, and then you can partially update the order using the patch API using the same order ID and a different set of data. And then finally you can delete the order ID using the delete API. You can delete the order, and then you again perform a get order just to confirm that whatever you deleted, that particular system deleted that particular order, and you receive a 404, that not found order in your response. This is how you can make the things work as an end-to-end test, and all of your data and the system as well as the APIs get involved performing each other end-to-end testing. So that is how you should perform a kind of an end-to-end testing. But make sure you have different assertions, like for matching the object, for matching the array, for matching the values greater than, less than, checking out the array contains respective fields or not, having a property or not, verifying the equals value, the value that equals to that particular field is coming correctly or not. Even a minor dot or an exclamation mark missing in your response can create severe consequences. I have observed that in my real-time project. So make sure that your API is returning the correct data in the respective format, and you are verifying each and everything as expected or not. I'll try to schedule. I have a question like, can you schedule one more session about mocking, interception, and schema validation? I'll look to it and see how we can make it feasible, and uh, have one more session with regards to that. But for this session, I think if there are no questions, then we can close this session. Thank you so much, everyone, for joining and making this a success. I can see a lot of people still watching this. Thank you so much for joining and helping me out and learning from the community today. Thank you so much.